Hello, this has been pre-written. All equations have already been solved. I'll just be walking through it since I can't quite figure out how to both hold the camera at a good angle and move around and work with my hand. It's very shaky last time I tried it. This is take 5 on the presentation, Linear Programming. Happy Easter. Linear programming is the maximization or minimization, if that's a word, jury's out on that, of this function. It's the objective function. It's what you're trying to, again, maximize or minimize, this z value here. The constraints are the laws this function must follow. It's setting boundaries on where this is. If there were no constraints, the minimum and maximum would just end up being negative infinity and positive infinity. It's not really ruling anything out. So moving on, we've written an example function. I've written an example function. Nobody else did anything. What the freak? Z equals 5x plus 3y. This is what we'll be using. And the constraints here, x is greater than or equal to 0, and y is greater than or equal to 0. This rules it out. This is the first quadrant, since the values of x and y must be positive, and the first quadrant is the only place both of those are true. Further constraints, x plus y is greater than or equal to 7. 4x plus 2y is less than or equal to 40. First, we have to find the intercepts of these 2 points, or these 2 functions, these constraints. We do that by plugging in 0 for x or y, depending on the intercept we're trying to get. We'll connect the dots, kind of, just drawing a line between those 2 intercepts for each function. For this one, we've solved x plus plugging in 0 for y is greater than or equal to 7, and 0 plus y is greater than or equal to 7. We've plotted that below. We'll show it in a minute. Further, 4 times 0 plus 2y is less than or equal to 40. Once we've eliminated this, since anything times 0 is 0, we can divide by 2 and get y is less than or equal to 20. Plugging in the same for y, 4x plus 2, 0, again, nothing here. We can divide by 4. On each side, we get x is less than or equal to 10. Below, I've plotted the points. We have 0, 7, which is these equations here. So 0, 7, and 7, 0. This is the x and y intercepts, respectively. And the other function is 0, 20, and 10, 0. Because in this constraint, this whole function is greater than 7, it means everything up or to the side on both ways, everything is greater than 7, because everything in between them also happens to be greater than 7 for each point. We would shade up. And likewise for this, it is less than or equal to these values. It is anything below these, and so it is also anything below and in between them. I've simply erased everything else here. This is the constraint. This is the boundary. Think of it like the border it has to operate in. The pen is throwing off the focus a little bit, but that's okay. You get the idea. Solving these, pre-solved, since again, I didn't know how to do this while holding a camera. 5, 0, this is the point down here. We'd solve it 5 times 0, 0, plus 3 times 7, which is 21. We get z equals 21. Again, since we're solving for the z value here. So 5 times 0 again, nothing, plus 3 times 20, which is this point, z equals 60. All the way down, z equals 35, and z equals 50. Since these are the only points that really matters, we can see the absolute lowest and the absolute highest it can be within these boundaries. So we have the minimum function, the minimum value, sorry, is z equals 21, and the absolute maximum it can be within these constraints is 60. This is a immediate application to fields such as engineering and production and business, where you're trying to get the most efficiency you can with the least resources. Very useful stuff. Yeah. Happy Easter, by the way. So far, posting this to YouTube has been more complicated than the equation itself. But yeah, this is linear programming. It does get more complicated than this, but I couldn't be bothered.